So very good afternoon to one and all. So today we are going to discuss about the calculations of balance of photovoltaic system. This sheet comprising of a ready-made design of solar PV system. In that case, user has to enter the load pattern. The load pattern comprising of type of the load, its voltage capacity, number of unit of such load used in the home, and their operating hours. So before pursuing this sheet, I will try to explain how to use this sheet. So in that case, you need to enter the required data in terms of load pattern. As the PV is generating a DC power, in that case we need to convert that DC power into AC because our loads are AC in nature. So for that case we require an inverter and the converter assembly, that is DC to AC converters and DC to DC converters. So in that case we need to assume the efficiency of the charge controllers as well as inverter and the battery itself. So in that case the efficiency range is also mentioned in the Excel sheet. It is there over here. Similarly, we need to assume within the range. However, you can assume any percentage efficiency, but as those elements are static in nature, the efficiency is handsomely good. Then you have to enter the sunshine hours. Usually it is 4 to 5, maximum 6 hours, where we can have enough penetration of power from the PV. And before proceeding further, one has to read the assumption rules before taking the assumption, and at last your plant is ready. So if we can talk about the problem statement, you are having a design of solar PV system for a house which contains some following appliances. These following appliances are user defined. So what I took is a fan, 50 watt each capacity, the 3 units, means 3 fans are there. So my total power is 15 to 3 is 150. I am assuming that fans are operating for 4 hours and the energy is 600 watt hour. Likewise we will go for the tube light and the refrigerator. So at the end of the step 1, that is AC load chart entered by the user, the outcome is the total watt. You can say watt consumed per specific time, that is your watt hour, that is 2820 watt hour. Similarly for step 2, we need to go for the electronic component selection. In that the Excel is designed such that this 490 watt has been directly coming over here. Similarly that too applied on the energy calculation. Now in that electronic component selection step 2, our first sub component is the inverter capacity selection. Usually inverters are rated in VA or kVA or MVA capacity. Over here, as we are designing a small power plant, our capacity of the inverter in VA or hardly 1 or 1.5 kVA. So in that case, if we are assuming the efficiency that is 96%, accordingly my VA output will change. Suppose if I can change the efficiency from 96 to 95, accordingly my VA output has been changed. I am trying to tell the same calculation of 96%. So in that case 510 VA is my answer. Similarly we can do it for the energy calculation, that was also found in the step 1. So for the learning outcome of step 2 subpoint A, we have a total input VA of the inverter is 510 VA and the watt hour is 2398. This is our AC power. 490 is our AC power. Our next section is the solar charge controller. So in the solar charge controller section, we are having a watt hour. There has been new watt hour computed over here, and new wattage is there with us. That is 490. That's what the actual one. For this, we required a DC current. So in DC current, we need to assume a suitable amount of the DC voltage. That is voltage of the charge controller, and same voltage that we can take over here for the battery selection. Now this 2398 and is watt hour and 490 is watt, and the voltage is 24. So if we need to find the current, that is 490 upon 24 is the 20 ampere approximately. I can take a 20 over here. This is the step 2. In the step 2, electronic component selection, sub point B, what we will get from this? Maximum current in ampere. Similarly, step 3, the battery capacity. In that case, we will go for the battery bank sizing. Now this is depending upon the autonomy needed. This entire design has been done for the zero autonomy, means there is no autonomy backup for entire day. This battery works as a backup for a single day or less than that time. So in that case, we need to go for energy, that is whatever is there with us. The voltage, that is what we took over here. We need to take the same voltage over here, so we'll get the ampere hour. Now after having ampere hour of the battery, we are not consuming all the capacity of the battery, so we need to assume the DOD in percentage. The DOD is nothing but the depth of discharge. So it has been defined as the percentage of total charge that can be used for the running load is referred as DOD. So if we can assume 70 DOD, 70%, it means that among the available capacity, only 70% of the total energy used can be, total energy stored can be used in this case. Suppose if we can do it, similarly this data is going to be changed. So this is what the case in terms of AH. Again, your required capacity is more. Again, if you go with 80, your still required AH is less. At 100, you will get the same capacity of battery AH. In this case, we are assuming 70% of DOD. We are going to approximate it as 175 AH battery. However, for any other theoretical design, if you get 180, 190 answer, you may select 200 AH battery that is available in the market. Now one important segment is step 4, that is sizing of SPV. How much PV module power is required. So for that, it is divided into two parts again. The first is the energy calculation and second is the power calculation. Energy will obtain the power. It's a reverse calculation. That's what we obtained earlier in the step 1 in the forward way. So in reverse way, what we have a total energy that is 2938. In this Excel sheet it is available and it is already typed automatically over here. Now likewise, inverter, we need to assume the efficiency of the battery, that is 95%. So in this case, we will get the watt hour capacity required from the SPV module. So it has been pasted over here directly. It is 3092. So again, what we have done this 2398, that is one efficiency has been incorporated of the inverter and second efficiency is also accommodated with the battery. So it's a charge controller and the SPV. So we are going reversely. We have started from the load, then we have done for the inverter, then we have done for the battery, and then we reach at SPV. So in this design, if we are assuming the number of sunshine hours is 4.5, we will get the SPV wattage is 687 watt. So if we can change it, so for example, if I can take 6, accordingly the wattage from the SPV module will change, because we require less amount of power from the SPV module compared to what we are having for 4.5 hours. In similar case, if we can go the more number of assumptions in hours, so at that time there is also an issue of the high temperature during afternoon. So at that time the open circuit voltage of the PV will be reduced, and hence your output will be reduced. So if I am assuming this 4.5, we will get 687. And in step 5, wiring and other accessory, the outcome of this step 5 is that you will get certain amount of current at 230 volt. It's a single phase inverter. If it is 3 phase, then you will go over the phase voltage or the line voltage accordingly. So our next step, sub-step, is maximum direct current and the voltage required. That is, this 687 is coming from the SPV voltage. The 24 volt, that's what we assumed for the DC supply. It is assumed over here 24 volt. It might be at 12 or 48 depending upon the user will get the current. So my DC current is 28.6. Similarly, according to this current and this voltage, we will select the standard wire gauge and switches of the main junction box. Now if you can convert into alternating voltages, we have AC power, that is 490 watt. The system AC voltage is 230. Then my current is 2.5 ampere. So from 28.6 ampere DC current, when it has been transformed into the AC via converter, your maximum current is 2.13. round off, I will get 2.5 ampere. So we can select the AC wiring, fuse and junction box of at least 2.5 ampere capacity that it can protect. So ultimately the system can supply 2.5 ampere and 230 volt from the PV if we are using this much amount of load. Now friends, I have already circulated some sheets to you via email. Each and every roll number comprising of different load pattern. You need to accommodate loads over here. Accordingly, your watt and whatever will be calculated automatically, that you can accommodate over here, watt over here, whatever over here. Then you may assume suitable amount of efficiency. According to that, the system power output will be changed, and the V capacity of the inverter has been computed, and the watt hour including the losses has been computed. From that watt hour, you will assume suitable amount of voltage or the system DC voltage. You can refer this section for the assumption of the voltage ranges. You will get the DC current. As you will get the DC current, you will get this over here. Then you can accommodate as it is the system voltage as same as the DC voltage of the battery. So battery rates in ampere hour. So watt hour divided by volt, I get the ampere hour. I am assuming suitable amount of depth of discharge, and from that you will get some approximate AH. Similarly, from the energy calculations, we need to add the efficiency of the battery in the energy, so you will get the approximately 3 kilowatt hour energy requirement from the solar module. Usually these calculations are done for the per day basis. So similarly, we are having 3092 and 4.5 hours of the daily sunshine hours will get the module wattage. So it is 687. Usually 3 modules of 250 watt is a good choice, but for ideal design, if you can go for the 4 modules 250 watt each which comprising of 1 kilowatt of solar power, then this extra energy or extra power in this case, extra energy in this case, will be diverted to the battery. So this is what the design. And at last, in step 5, by converting DC into AC power after inverter, you get 230 volt and 2.5 ampere for the supply that has been generated through PV and battery. Now after the end of this vacation, you need to submit this thing in the hard copy, and before 7th April 2020 you need to submit the same in the soft copy of in the Google Sheet that has been circulated. So hope you got the things. However, the time slot is given to you. If any doubt, then you may email or you may call at the given time. Stay at home, stay healthy, stay safe. Take care. Wish you all the best.